The night sky is adorned with countless stars, their patterns changing with the seasons. Who do you think were the first humans to observe them? Was it the ancient Greeks, who crafted myths from the starry sky? The Egyptians and Mesopotamians also left many ruins and legends related to the stars. But wait, the very earliest might have been someone quite unexpected. Australian Aborigines. Actually, they could well have been the world's first astronomers. Evidence of this has been mounting in recent years. Consider these rocks. The line they form points directly to the setting sun on the winter solstice.
Chances are this is much, much older than Stonehenge. It could be 10 times as old as Stonehenge, and yet people are doing similar things here.
Strange rock paintings like these are also found all over Australia. The Aborigines used the motion of the stars as a calendar. On journeys, they looked up at the night sky. They had surprising navigation technology that enabled them to use the position of the stars as a map. Their understanding of astronomy has apparently been passed down in the nation's genes. Today, Australia leads the world in the field of radio astronomy. Living on a remote continent, isolated from other civilizations, the Aborigines developed a sophisticated science of astronomy without a written language. How did they do it? The secret lies in this vast and forbidding landscape.
So firstly, it's historical. We have a tremendous tradition of doing astronomy in Australia. So Australia's only a small country, but it's always been good at astronomy.
The Aborigines of Australia are believed to be the world's oldest astronomers. This program will explore their remarkable achievements. Australia is a vast, arid continent. Isolated from other civilizations, it developed its own unique ecosystem. Ruins were discovered here that might overturn the accepted history of astronomy. We visit Wathaurong, the home of Aborigines in the state of Victoria.
Yep.
The word Aborigine is derived from Latin and means original inhabitants. Aboriginal people have lived in Australia for about 60,000 years. Today, about 120 tribes remain. This area is the home of the Wathaurong tribe. Intermarriage is now common, so that many tribe members look Caucasian. Still, they continue to protect their land and their culture, as they have since ancient times.
Now I'd like to invite you into the land and into the smoke traditionally like our ancestors would have done. Please come into the smoke and have the cleansing service. Okay, come in and just go like this, welcome.
This is a rite of welcome for visitors to their land, called the smoke ceremony. Visitors are purified by smoke and given permission to enter. After the ceremony, tribal members guide us to a site that has long been under their protection.
Overhead just comes straight. Yeah, yeah, that's right.
Tree stone.
That's where that line comes down. And that line comes down.
Kind of sunburn, I think.
Yeah.
About 50 large stones are arrayed in the grassy plain, forming clear lines. They're known as the Wurdi-Yoang stone arrangement. But what do they have to do with astronomy?
Yeah.
Ray Norris of Australia's Commonwealth Scientific and Industrial Research Organisation has long studied this question. He says that Wurdi-Yoang is special in the layout of its stones.
It's a ring of stones about 50 metres across. And you can see there's a line of stones up here, and a line of stones up there, and then they're connected by this large semicircle at the top.
Let's take a look from the air. The rocks clearly make a fan shape comprised of two straight lines joined by an arc. With a diameter of about 50 meters, it's a very large site. But why was it created? Scientific studies of the site, begun in 2006, have led to an amazing discovery.
So they've built this line of stones here, and that points towards the place on the horizon where the sun sets on Midwinter's Day. And over there is a line which points towards where the sun sets on Midsummer's Day. The Watang people were really interested in knowing exactly where due west was and knowing the motion of the sun.
Two lines extend southwest and northwest from a central stone. Viewed from the stone at the winter solstice, the sunset aligns with the northwest line. At the summer solstice, the sunset aligns with the southwest line. At the spring and autumn equinoxes, the sun sets midway between the two lines. In this way, the site serves as a calendar that marks the seasons by means of the sun's position. We filmed the site on the day of the winter solstice in the southern hemisphere, waiting for the sun to set. It definitely set in the position indicated by the line of stones. Even today, the site is amazingly accurate. Modern-day Aborigines were also surprised by the research results. Reg Abrahams of the Wathaurong tribe has been a leader in preserving the site.
It was a mystery because it was just pretty amazing that it has that solar indicators, I suppose, with astronomy in that. Because, yeah, it's just mind-blowing, I suppose. Hopefully prevent it from any more erosion.
Norris's subsequent research results increase the likelihood that the Wurdi-Yoang site is the oldest astronomical observatory in human history.
Part of the Yuyang's over here, and one that mimics, Mount Blackwood.
Yeah. This site is incredibly important if we're trying to understand how humans have looked at the sky over the course of human history. This is probably one of the earliest examples of people really studying the sky in detail.
It raises the question, when did the history of astronomy begin? No one knows for sure. But the ancient civilizations of Mesopotamia and Egypt had already developed sophisticated astronomic techniques before the Common Era. There's a famous site that, like Wurdi Yoang, features stones placed in a circle. Stonehenge, in England. This too is thought to be an observatory. It was built in about 3000 BCE.
Many people think of Stonehenge as being perhaps the oldest observatory in the world, but this is much, much older. Well, again, we don't really know the age, but given that Aboriginal people have lived here for tens of thousands of years with a continuous culture, chances are this is much, much older than Stonehenge. It could be 10 times as old as Stonehenge.
It's surprising to think that Aborigines on the Australian continent developed astronomy long before other ancient civilizations did. How did the Aborigines actually observe the celestial bodies they saw in the sky? Norris is conducting surveys with various Aboriginal tribes to try to piece together a clearer picture. He travels about 400 kilometers south of Darwin to visit an outback village inhabited by members of the Wardaman tribe. He's greeted by Bill Harney, a tribal elder.
Good. You're not finished, but...
Harney is 84 years old. He's a human repository of deep tribal knowledge, passed down through generations, all kept in his head. Norris has learned many things from Harney related to Aboriginal astronomy.
Every time I meet Bill, he tells me something different. He tells me something I didn't know before. You start by learning the very simple things. And every time I meet Bill, he takes me a little bit further on that journey and helps me understand something else. Because the knowledge in his head is enormous, it's so complex.
Today, Harney takes Norris to a place where ancient evidence of Aboriginal astronomy can still be seen. Traveling 30 minutes from the village through grasslands, they arrive at a sacred site where ancestors of the Wardaman tribe once lived. Greetings must be spoken to the ancestors before entering.
That's amazing.
Harney shows Norris rock art that's said to be 5,000 years old. Kangaroos, emus, and wild dingo dogs. Many kinds of living things are depicted on the rocks in red and white clay.
You can see here, that's where the half moon, when the new moon comes on.
Right, okay.
In the center, there's a symbol of the new moon. It's shown with a long, thin body and round face. Harney says the decorations in the hair around the face represent crescent moons.
That's the new moon that represents.
Yeah.
When in the evening you can see the new moon over there,
Yeah.
you know, the big king tide.
Right.
There are many big rivers going into the sea.
Yeah.
The big river comes in a big flood backward,
Yeah.
upstream.
Yeah, yeah.
Because a big king tide, you know. And then when he goes back to normal tides, he sit down.
As the new moon approaches, its gravitational alignment with the sun produces the rising waters of a king tide. That in turn temporarily reverses the flow of the rivers, which causes flooding. Based on their observations, Harney's ancient ancestors understood the relationship between the moon and the ebb and flow of the tides. The rock art also contains pictures of the ancestors' unique star constellations.
See, this red one here,
Yeah.
that's a big catfish. Huge,
right.
big catfish.
Yep.
Some small catfish were they got across, but the small one, but the big one really show
Yeah.
on their head. That catfish now, he's in the Southern Cross.
That's right. The Southern Cross, the same constellation that adorns Australia's national flag. But the Aborigines say that it's the head of a gigantic catfish. Their stargazing sensibility is very different from that of Westerners, isn't it?
Many, many years ago, been passed the story, been passed on all the way to the people, right up till they said, you've got to learn all this. And they all lay back in the back, and then we'll sit up and lay too. Then we got to tell the story.
The Aborigines' awareness of the stars is reflected in their songs and dances. Without a written language, they relied on oral transmission to pass down their village rules, day-to-day knowledge, and culture. Myths related to the stars are part of that cultural fabric. It's said that this myth about Nardi plays a role in teaching children morals.
Well, I watch these kids and everything in a spiritual way.
Yeah.
Sing the word and song in their mind. You know, tells them what to do, not to go out of hand. And every kid will come in a piece when they walk around.
Yeah.
The mad kid, they call Jordan. You have to get straightened up by the song.
Okay.
And then they straighten them up with the song.
At night, the village is wrapped in total darkness. The stars shine bright.
That lot, they're the boss man to create the land. They made this land for all of us to live here now today. We sit down here like this country now, from Dunga and Nada. Dunga will make this dirt for we to walk around. Now they've been making the sky for all of us to look up to make it bright. The water.
Since long before the Greeks of the West created their myths, Harney's ancestors looked up at the night sky and created stories they have passed down through countless generations. The Aborigines have made clever use of celestial bodies since ancient times. Proof of this can be found in another tribe. the Not region in the state of South Australia. Here, evidence of Aboriginal astronomical observations is carved on a stone wall.
All of this stands for the creative spirit, the Wajana ceremony with the celebrating of the moons, the days up to the ceremony, the tools used for the ceremony.
In this pattern, the circles above represent full moons. The pattern shows that a ceremony is held after 10 full moons. The smaller circles below show the number of days it takes to walk to the site. In this case, it takes 21 days. In other words, this tribe used the moon as a calendar. The shape up above also has a meaning. It's a boomerang, the typical weapon of the Aborigines. Necessary for hunting, it is also used in sacred ceremonies. The image here means that a boomerang must be taken to the ceremony.
Moon, like everything, is a part of a calendar, like the days or things like that, yeah.
There's one more image that demonstrates the amazing observational skills of this tribe.
This here is the sun symbol. It represents the women. The women came under the sun because they were the gatherers. They went out and got all the fruits.
Take a close look at this sun symbol. Do you see the 9 small dots? What are those?
And those dark dots there, that it's sort of like a mirror vision or the reverse from a puddle. When it rains, you'll see those dots in the puddle.
The ancient Aborigines seem to have detected sunspots, a phenomenon that wasn't observed in detail by Westerners until the 17th century. In a time when there was almost no technology to aid observation, the Aborigines apparently knew that sunspots existed. If true, it's an amazing fact. It all leads to the question, why were the ancient Aborigines so intensely involved in astronomical observations? It's believed that the Aborigines first arrived on the Australian continent some 60,000 years ago, following along the Indonesian archipelago by boat. They were met by a harsh natural environment, a vast and extremely arid land spread before them as far as the eye could see. The red earth that covered the ground had few nutrients, making farming difficult at best. It was only natural that the Aborigines evolved into nomadic hunter-gatherers. As such, they found it crucially important to know when food sources in nature could be harvested.
And you've got to know the right time to move. If you move at the wrong time, then the birds will have eaten the berries, and it'll be too late. The fish will have gone out to sea, or they won't be spawning. And so it's very important that you have a good calendar. And we see this across Australia, that people use the sky, and they use other things as well, to tell them what time of year it is.
How did the ancient Aborigines use the night sky to help them find food? Jimmy Smith helps us to understand.
What did you get?
Emu egg.
Tell me, please.
An emu egg? It sure is big. Found throughout Australia, emus are large birds. Their eggs are an important Aboriginal food source. But what do emu eggs have to do with astronomy?
This is the emu here. Goes like that, all the way around down. And its long neck coming back to the body here, and goes all the way up and around. And the legs, they're tucked under.
There's no mistaking the image of an emu carved here in the rock. Many Aboriginal tribes have made murals and stories about emus, but Smith says that this image is not a picture of an actual wild emu.
There's a good chance this came from the sky one, and knowing what it was. They're tucked under, so it's flying across the night sky. Eh?
What? That's strange. Emus aren't able to fly. What does Smith mean when he says this one came from the sky? To find out, we wait for sunset. Looking at the southern sky after dark, we see the Milky Way. Can you find any sign of an emu there? Look at the dark patches. See? The image of an emu is indeed floating in the night sky. The black patches are actually dark nebulas. The Aborigines focused not on the shining stars, but on these dark areas. The changing appearance of this celestial emu provided ancient astronomers with important information.
Koori people know from astronomy, looking at the stars, that this is the time to go out into the bush and look for the emu nest.
Emus begin mating in May, at the beginning of winter. At that time of the year, the emu in the sky has a vertical slant. Around August, the position of the emu after sunset has rotated to a more horizontal position. Now it looks like a nest holding an egg. In other words, the angle of the emu in the sky indicates the season when people can find eggs.
Koori people come around behind with coolamans and dilly bags and collect the eggs. And it comes from astronomy. This tells us what time, what food source is available.
For tens of thousands of years, the Aborigines have consulted the starry sky to support themselves through hunting. In this way, the vast land of Australia gave birth to the rich Aboriginal astronomy, which can be called the oldest in the world. Steady research has gradually clarified the nature of Aboriginal astronomy, revealing further surprises. For example, some tribes use the starry sky as a navigational aid.
Michael.
Today, Norris visits the headmen of the Yuwalai tribe, who live in the outback of Queensland. His name is Michael Anderson. How do his people use the stars for navigation?
This is what happens when the drought comes. That there is a frozen drought. Motor car.
The Aborigines sometimes made long journeys to visit other tribes for trade or to participate in ceremonies. It was then that they used the night sky to point the way.
So mate, yeah, so where are we at the moment on here?
We're there.
Good. Right, okay.
Yep.
And so what are the places you went to?
Well, the old people used to talk about, they used to come up here into the Bunyas.
Right.
Into the Bunya Mountains.
Bunya Mountains, right up there.
Up in there.
Yeah.
So that's, distance-wise, about 600 k's away.
Well, that's a fair walk.
Yeah, it's a good walk.
Yeah.
A few months, yeah.
To stay on track during their long treks, they used distinctive rock formations or watering holes as natural landmarks. Each landmark was the subject of a myth.
Michael, what is that? What is it?
Here is where the emu had a fight with the red-bellied black snake, and he left his print in his belly, inside his stomach.
A rock bearing the footprint of an emu. This is one landmark Anderson's tribe used.
These here, as we're travelling across, we know we're going to come across one of these here. So because as a young man, when I was taught, I taught where the camps were. So in between those camps and along the way, you will always find these story places.
But it's difficult to convey the travel route solely through words. Many rocks and lakes look alike. The travelers needed something more concrete and unchanging. To fill this need, they used the stars as maps.
The lighter ones. So when you look up there, you see the bright ones.
Yeah.
That's your story place. That's
Right.
where the big water holes are. And then the lighter ones are a lot of campsites where we camp along the way.
So that big bright red one.
Yeah. And that there bright one,
Yeah,
red
so-
one, is Torwood.
So we'd
That's
call
in
it
Queensland.
Antares. That star, the astronomers call it Antares. Right up there is Scorpius. So you're using Scorpius, is that right?
If we want to travel to the mountains, to the Bunya Mountains, we will use Scorpius.
But how did the ancestors actually use the starry sky as a map? This is the path they took to the Bunya Mountains, one of their destination sites. There are various places along the way where they met with other tribes and found water. They needed to remember the way. The stars served as a memory guide. Guduga is represented by the star Zeta in the constellation Scorpius. Traveling east from there, they arrive at the star Theta Scorpii, where water can be found. The next watering hole is found even further east, at Eta Scorpii. In this way, by following the line of bright stars, the Aborigines could remember the path they needed to take. The star map served as an aid for making long journeys. Through their ingenious use of the night sky, the ancient native peoples found a way to traverse their huge continent. Surprisingly, Anderson says that star maps are still relevant to modern life.
If you sat down and precisely mapped it, just as we've done with this one, we're doing it there, you'll find that most of these roads are in fact following songline stories.
Yeah.
Yeah.
Take this star map, for example, which has Gaduga as its starting point. If we take the line created by the map and overlay a map of modern roads, see? They align very closely.
And I guess that's when we white fellas came to Australia and people were trying to set up these roads, they'd often ask for Aboriginal guides.
In the 18th century, Captain James Cook's expedition reached Australia. By that time, the Aborigines had established a network of trade routes that spanned the continent. When the Europeans settled here, they may well have created their modern road system following the paths that Aboriginal ancestors walked for thousands of years while looking at the night sky. Aboriginal astronomy was born precisely because Australia's environment was so harsh. That deep connection with the stars continues to contribute to the development of modern astronomy today. Many important discoveries have been made here at CSIRO Parkes Observatory.
Yeah, so you can see the telescope. It's 64 metres in diameter, and when it was built, it was the most advanced radio telescope of its kind in the world. And
this facility uses radio waves instead of light to observe the universe. Australia has been a world leader in radio astronomy for many years. But why has the field bloomed so successfully here? The answer lies in a special characteristic of radio wave observation. Radio waves emitted by celestial bodies are very weak, making them difficult to observe from the surface of the Earth, which is already saturated with many kinds of crisscrossing radio waves.
to put it into context, if you imagine, I have a mobile telephone here. If I was to switch this telephone on and place it on the moon itself, 400,000 kilometres away, the Parkes telescope will be able to detect it very easily.
The Australian environment is well suited to radio astronomy. It's relatively untainted by radio noise, with many locations where one can view the horizon in a 360-degree circle and see nothing but outback. This advantage makes the Parkes Observatory a world leader in radio astronomy. Of its many achievements, their observations of one type of celestial body in particular have proven especially notable.
I have an example of one here that I did a few years ago, and if I was to open it up, you can see here the train of pulses. We call this a pulsar train, so it goes like that.
The objects in question are called pulsars, which are neutron stars that revolve at high speed, emitting bursts of radio waves toward Earth at regular intervals. About 2,600 pulsars have been identified worldwide. More than half were discovered independently at the Parkes Observatory. There's a geographical reason for that.
But also our location. The centre of the Milky Way passes directly overhead. A lot of these pulsars lie within the Milky Way, along the plane of the Milky Way. And so if you can see most of the Milky Way you're going to find most of the pulsars.
Today, as in the past, the Parkes Observatory is used by researchers all over the world to observe pulsars. The facility is an essential presence in the astronomy of the 21st century. An unprecedented project is underway in an arid region in the state of Western Australia. ASCAP is a new and highly advanced facility, featuring 36 antennas with diameters of 12 meters each. It has nearly twice the collection area of the Parkes Observatory. One purpose of this facility is to observe a mysterious phenomenon that has recently been featured in a prominent science journal. It's called a fast radio burst, or FRB. Discovered by Australian scientists, it's currently the most talked about cosmic phenomenon in the world. These mysterious radio waves have a special characteristic. They deliver extremely high levels of energy that peaks instantaneously.
Like this, and it's very fast, so it starts and finishes in about 1/1000th of a second, or 1 millisecond. So it's very, very fast. They were very surprised to see that. They weren't looking for that. And what made it so interesting was that it looked like the burst happened a very long way away. And that's really interesting because we don't understand how anything can make a fast radio burst so quick and so bright.
Subsequent research has confirmed that thousands of FRBs flare across the cosmos every day. The total energy of the FRBs is equivalent to the daily energy output of 500 million suns. And yet, no one knows exactly what they are or what object could possibly emit such strong, short-lived radio waves. It's a deepening mystery.
We don't really know what causes FRBs. In fact, it's the subject of a huge amount of speculation. In fact, there are probably more theories for what causes FRBs than there are actually FRBs that we know. So it's a really open question, and that's one of the reasons why FRBs are so exciting, because we don't know what they are, and we can't really think of a good explanation for them.
With its wide collection area, ASCAP can detect many FRBs. Hopefully, this will help scientists solve the riddle of their true nature. In addition, ASCAP is playing a central role in a new global project which has the participation of 20 countries. This huge project involves the installation of several thousand radio telescope antennas in South Africa and Australia. It is called the Square Kilometre Array. Once completed, this next-generation radio telescope project will be able to scan the skies with greater precision than ever before.
And SKA will be really exciting. So when that happens, we're really well placed to be able to build things for that telescope, work with the people who built it, and also use it to find out things about the universe. So it's a very exciting time. Pretty happy about it, actually, not surprisingly. I mean, it's a great privilege to work in radio astronomy, and it's great to be in Australia where it's so well, it does so well.
The highly advanced ASCAP telescope has another special feature.
Antenna number 3, Bundara. And also we have the explanation down here. So there's a Waju name for star.
Each of the antennas has an Aboriginal name. Actually, the telescope is located on land that has long been revered and protected by the Wajadi tribe. Wanting to cooperate with cutting-edge scientific research, the Wajadi offered their land for use by the project. Leonie Boddington, a member of the Wajadi tribe, is now on the project staff.
I feel very excited that, like I said, we've got CSIRO, you know, one of the leading scientific organisations in the world on our country, on Wajiri country. You know, we could get our Wajiri children involved, or anybody has an interest. So quite a few, that are interested in what's going on out here and what they're finding.
The Aborigines of Australia have preserved and protected their lands for millennia. And now, they're also supporting cutting-edge astronomical research. Celestial bodies have been observed on the Australian continent for countless generations. Recently, that history has given birth to an important technology that supports modern life. Formulas used in radio astronomy to convert radio waves into digital data made it possible to develop high-speed wireless telecommunications. This technology, commonly known as Wi-Fi, was instantly disseminated throughout the world and has become a supporting pillar of our lives.
If I see how widespread Wi-Fi has become, I'm amazed in many ways. So we always thought it would be big, but now we see it's in mobile phones, it's everywhere, and I'm just blown away.
60,000 years ago, Aboriginal astronomers looked up at the stars from a vast continent in Earth's southern hemisphere. To survive a harsh environment, they observed the stars and passed on their knowledge of how the universe works through countless generations. And now, Australian astronomers have accepted the challenge of new cosmic puzzles.